So in section 1, we are going to cover some basics around IoT and blockchain. So let me get started with that. So first of all, let's go back to the actual beginnings of IoT, what it is and how it actually came into picture. First of all, so in 1999, if I'm correct, Mr. Kevin Ashton actually came up with this term called Internet of Things. And his primary premise for coining this term and for coming up with the whole concept around it was there is a lot of data available, but human beings are all current. At that point in time, it was only human beings or us who were sending in data to the systems. And we were not very good at it. There was a lot of data available, but we were not fast enough. We were not accurate enough that all of this data can be entered manually in all the systems. So we needed a way to find out how this data can automatically get into the systems in the more accurate way, so that human intervention is less and the systems are ultimately more accurate and less error prone. So that's where he coined the term called Internet of Things, where instead of human beings connecting to the internet and entering the data manually, things or devices can directly connect to the internet and submit the data. So that's how the overall terms about Internet of Things came into picture, that even things can start using the internet. And this is coming from the very beginnings of IoT, like when it was really coined in the beginnings. Now, what from my perspective, how I understood IoT and what we are looking at here is, it is actually a combination of two things. One is automation, which Mr. Kevin Ashton was primarily talking about, that there should be a way of sending the data automatically into the cloud systems or internet systems. I will interchangeably use cloud and internet because somewhere or the other, that's the general term being used these days. But please don't confuse with in between those. It's just interchangeable for the context of this presentation. So, and the second more important thing is, once you have all this data in these systems, what will you do with this data? Why are you even putting all this data in the systems? So you will analyze it and you will find out results and learn about things, so that you can make these systems better for the future, make things better for the future. So those are the two primary parts or concepts around IoT. One is getting the data into the systems more accurately and with less human intervention. And second one is, once you get this data into the systems, you extract out the results from this data to learn about things which are sending this data, to learn about the environment of those things. So those are the primary two aspects of IoT. And then let's briefly look at blockchain. So we see a lot of blockchain systems in the market today. We see a lot of networks coming up, a lot of ICOs happening, and this is actually a lot of applications of blockchain. They are not blockchain in themselves, they are applications.
Welcome to the webinar. You have entered as an attendee in listen-only mode.
Can you please go on mute, everyone? Thank you. So what I was saying is, all these things or all these networks or systems that are coming up in the market today are more like applications of blockchain. The fundamental concepts of blockchain are very simple. Actually, they are not complicated at all. So there is no default product or platform or service when we talk about blockchain. It's more of an approach. It's a way of doing things. Actually, it's like a protocol that has been defined how things can be done in a different way, and that's more or less blockchain in itself. Now, on top of that, there have been a lot of applications developed in the recent past, mostly in the last 10 years. Uh, and the most important ones are, the most popular ones are Bitcoin and Ethereum. So those are two application based on the blockchain platform or blockchain protocol, actually. When I call it platform, even I'm incorrect in that way as well. So let me correct myself. It's a block. They are based on blockchain protocol. Now, some of the features of blockchain and why these applications are different from the regular conventional applications is because of these three features, which are there on the slide currently. So the first of and more important feature is decentralized. Blockchain systems are decentralized in themselves. And by decentralization, I mean all the data which is being submitted into the systems is verified by multiple parties, is stored and verified by multiple parties. So it is not going to be one single database sitting in a data center somewhere and all the data going into that database. In blockchain systems, it's going to be a lot of these kind of databases at every party which is involved in a network. And all of these parties will be independently and individually verifying and storing this data. So that is decentralization. So the primary purpose of decentralization is there should not be a single point of failure or control in the system. So in general, when you have conventional centralized systems, you most of the time you have a centralized server or centralized database which can be hacked, which can be controlled by hackers or unauthorized parties. But in blockchains, because you have a lot of copies of the data, if you change it at one place, the other parties will say that the data is unauthorizedly changed. So that is the more importance and point around decentralization. The second more important feature is immutability. So the data which is committed to the blockchain cannot be changed or deleted. And this is actually also, I would say, complementary to decentralization, because if you keep on changing the data, then everybody storing the data has to go back and change it, which is not very performance friendly and which is not very realistic. So once the data is committed by all the parties, they've all stored and verified it, you cannot change it anymore. You cannot delete it because, again, there is no single point of control. So there is no single point of deletion also. So once everybody has a copy of data, you do not have control to delete it anymore. So that's where immutability comes into picture, that you cannot change or cannot delete. And the third one, and complementing these two features, is cryptographically secured. So blockchain systems are also cryptographically secured by a way of signing the data. So all the data which is submitted or inserted into blockchain systems is cryptographically signed by each of the party which is sending this data. By signing, what I mean is basically you use public key cryptography to sign the data, create a digital signature out of this data, and augment the data along with the signature, so that it is very clear that the party which is sending the data is associating their identity along with the data. So if I'm writing something on the blockchain system and I have cryptographically signed it using my keys, then I will be able to or all the other participants will be able to identify that this data is being signed by this particular public key. And if or it may or may not be possible to identify who is actual owner of the public key, but at least it is definitely identifiable what public key is being used for signing this data. So those are the primary three features of blockchain systems, and these are the features which make them very different from normal conventional systems of today, because in general today's systems have basically, if we look at any distributed system of today, it's more like a master slave scenario where a primary server is there are replication servers called slaves, and then we have distributed services. One service is doing something, the other service is doing something else, and then all of them combine together to create a system which is doing one particular thing at a time. However, all of these things are actually completely decentralized in a blockchain-based systems where every party is doing all of these things to make the system more secure and more, you can say, usable for the future. Now, at this point in time, I am actually I have covered the basics of blockchain and IoT, what they are, and now after this, basically the next thing that I want to talk about is the issues and concerns with IoT today. Because if we are talking about integration of blockchain and IoT, then there should be a need of integration. There should not be like we should, because these are two things in the market. They are pretty cool. IoT is in the hype cycle, blockchain is on the hype cycle, and we should integrate. That should not be the reason for integration. The reason for integration should be if there is an issue, then how can we solve that? And how blockchain can help in solving that issue. If it can, then we should integrate. So the primary three issues that we see today in IoT systems are, first of all, lack of trust. So there are a lot of devices out there, and in magazine articles, mostly there are some billions added to devices coming in the next few years. Sometimes it is 20 billion, sometimes it is 70 billion, and the number actually resolves somewhere between the two. So I'm not going to actually talk about the numbers of devices which are going to come out, but there is definitely a lot of devices being connected to the systems. And once these devices are placed at remote, faraway locations, we do not have a lot of control on these devices except uh, controlling them using authentication and stuff like that. So there is definitely some lack of trust in the systems of today. We do not know if the device is sending the correct data or not. We do not know if device is malfunctioning or somebody has overtaken this device and hacked it, and things like that. Then we have security issues, which are actually connected to the lack of trust itself, because of security issues, we are not having enough trust in the systems. But there are different kind of security issues with respect to the overall integrity of the data in the system itself. So if the device cannot be trusted, and if it is still sending the data and we are processing that data, then the overall state of the system is stale, or it's bad, and that is providing concerning and creating a lot more security issues for the systems who are downstream and consuming this data. And finally, because of these two things, we have to be involved and monitoring these systems all the time. So while the primary purpose for the whole conceptualization of IoT was less human interaction, because of these issues, we are actually going back to the same problem, that we have to create these monitoring dashboards. We have to create support teams which are there 24/7, providing supports and shifts, making sure that the systems are working fine, and there is a lot of money being spent in just supporting and overseeing the IoT systems. So these are some of the concerns that we have today with the IoT systems. And as and when the devices are going to be more and more, and they are going to be connected to more and more homes and systems and companies and organizations, these issues will be becoming bigger and bigger. So how can we solve these issues? What can be one thing that can help us solve some of these issues, I would say. Um, so that's where we want to see how blockchain and IoT can integrate and help us solve these issues. So before I go into section 2, I would like to take a small pause and ask if we have any questions at this moment. Or do you want me to cover something in detail before going into the integration section so that I can briefly talk about it? Okay, then I will continue with the section 2 of the webinar, which is blockchain and IoT integration patterns. So let's first of all take a very simple scenario of how blockchain and IoT can work together, and then we will go deep into each and every integration pattern that we have. So let's assume that there is a supply chain scenario. on one side of the supply chain, we have the logistical partners who are making sure that the goods are reaching the desired destination on time, and they want to be paid as soon as possible because it's a very fast industry, generally, the supply chain. And secondly, we have on the other side the administrators or consumers or the other parties which are actually waiting for these goods. Now, this is a subset of a supply chain, which is very common that every supply chain will have a distributor or a logistical partner, and the other party will be waiting for these goods to be delivered. Now, let's assume that both of these parties have their own have access to a network which is having a few blockchain nodes, and we are talking about private blockchain networks. If let me briefly clarify this part as well before we move on. So blockchains are primarily of two types. One are public permissionless networks. So when we say permissionless, that means everybody can go and join this network. For example, Bitcoin and Ethereum mainnets. So you can simply download the software, connect to this network, and start mining at your home or something similar. But then there are other kind of blockchains also, which are called private permission blockchains. So these blockchains are primarily used in organizations for between multiple organizations or inside the same organization between multiple departments to get more integrity in the data. And this is the current scenario that I'm presenting on my slide is basically a private blockchain scenario where a party in the system is the consumer and the party in the system is the logistical partner. And these two parties are coming together, creating a blockchain network. Both of them have their own nodes, and there is some condition which is stored in blockchain, and I will talk about it a little later. So if we go back to the characteristics of blockchains, we will see that every party will have all the data, and that's why I have two of these servers over here, because both these parties which are collaborating have their own copy of data, and these are all the data which is being sent to this network is automatically replicated. So if the consumer party is writing some data on the blockchain node, which is in their control at this moment, is automatically replicated to the node of the logistical partner and vice versa. And similarly, the other important characteristic, which was immutability, which comes into picture because if these parties are writing something on the blockchain network and it is automatically replicated over here, then they might be able to delete it from here, but they will not be able to delete it from here. So there comes immutability, that you cannot change anything because it is already decentralized. And the third one, more important thing, is all the data which is being written on these nodes is being signed by the authorized parties, or I would say is being signed by each of these identities which are there in the system. So the data signed by the consumer is basically identifying them, and the data signed by the logistical partner is identifying them. So we clearly know who has written what in the blockchain. So now this truck has to reach this circle, and this circle is the destination point. And if this circle, if they are able to make it on time, then we will then they will be paid in money. For example, let's say this truck has bananas, and bananas will go stale after a week. So they have to reach this circle within a week before, and that's only when they will be paid, because otherwise they are whatever they are bringing is becoming useless, and they should not be paid for a delay. So the truck reaches the required destination and it sends it location data. And this is the IoT part of the system. That the truck is actually sending the location data as and when it is reaching the destination. And we can have simple time and location, device over here, which is communicating the data over to the blockchain network of this of the logistical partner. Now we have the location, we have the time, and it is being written over here by the logistical partner. And we know that this location and time is being signed by the keys of the of the truck driver or the logistical partner, so that it's already cryptographically signed. And this is automatically replicating to this side of the network, because it is a blockchain and things are decentralized and they automatically replicate. So now we know that there is some data coming in, and that data needs to be acted upon. So as soon as this data is coming in, there is a condition which is placed by the consuming party, that if I get the bananas in within 7 days, then I will pay some amount to this logistical partner, and if the timeline is passed, then I will not be paying anything. So this condition is being checked and a payment is made. So if this condition was not checked, the payment would not have been made. Now the same concept of Bitcoin and Ethereum smart contracts are coming into picture. So actually this condition which is being checked is coded inside a smart contract, and I'm sure you must have heard about smart contracts, because they are really famous in the blockchain world. And then we have payment based on blockchain, which is also both supported by Bitcoin and Ethereum. For Bitcoin, it is actually the Bitcoin itself, and for Ethereum, it is the Ether, which is the native currency on Ethereum network. So if a condition is met on a smart contract, which says that if the truck which is identified by this particular public key is sending a location, and the location is within this geofence, then transfer some funds to this public key over the network. So what we are actually doing is we are doing the data validation and money transfer, or transfer of value between these two parties. And basically all of this is being done on the same system, which is shared by these two parties. So that's where the whole integration pattern or concept of blockchain connecting with IoT is coming in, where what we are saying is we are putting a layer of verification on top of the IoT data, and this verification layer is completely humanless, because there is no human interaction being made at this point. Everything is fully automated and fully secured, and because of that, everybody goes home happy. So this was one simple scenario of how IoT and blockchain are coming together and creating a system of value. Now, basically, because looking at this scenario, what we saw is that we had to do less oversight into the system, because no human activity was actually involved. Because of IoT, the location data was automatically coming in, and because of a smart contract, the payment was automatically made. Then we have better security, because because of decentralization, both the parties were actually fully in control of their nodes, but they were not in control of the entire system. So there was no single point of failure, and both of these parties were able to write data which was cryptographically signed by them. So there was identity attached to the data as well. And then because of, I mean, this last point should have been the first point, but and because of that, we are having less oversight. So there was an automated transfer and automated transaction and a value transfer inside the system, which was fully secure. So these were the benefits that we achieved from the integration that we just saw in the scenario on the previous slides. Now let's go into some architectural details on how these integrations can be achieved, because at this moment we are only looking at a user story or an overall you can say high level perspective. But let's do a double click and see how these integrations can be done in the systems. So from a very top level, high level, we have primarily three kind of integration patterns, and these three integration patterns are there are three because I am just covering three of them. There can be definitely many more, and there can be many more which will be known in the future. But at this moment, as per my understanding, we are looking at three primary patterns of integrating blockchain with IoT. The first one is basically identification of devices, and this is going back to the same idea of cryptographically signing everything which goes into the blockchain. The second one is validation rules, And this is a very small portion of it we saw in the previous scenario, where a smart contract was running in the system and it was doing the validation of IoT data. And finally, third one, and which is a little more futuristic, because the third one needs a lot more scalability, and blockchains are not that scalable today, which is called device on chain, or it is also known as other names also. It's called device to blockchain, direct communication, and some other names. But I will call it device on chain just for simplicity. So these are the primary three integration patterns that we can look at for integrating blockchains and IoT. So before going into them, let's quickly refresh our view on how generally an IoT system works. Now, this is a 50,000 feet view of how almost all the IoT systems work today. There are some changes in some systems. Sometimes there is edge computing, sometimes there is fog computing, which is the client side or the device side heavy, and sometimes there is more processing and a rule engine incorporation on the cloud side, so it makes the server side heavy. But in general, what we see is we have devices which are sometimes connecting to field gateway, sometimes they're not connecting, they're directly sending data to the cloud. And then we have an aggregation layer or ingestion layer, which is called a cloud gateway, which takes all the data from devices into the internet. And then we are basically collecting all this data, do some initial validation checks, and then storing this data in a database. And finally, we are looking at analyzing this data, creating reports and results, and learning about things which are, or learning about the environment or about these things which are sending the data. So this in general is the high level architecture or high level component description of IoT systems. And what we see here is there are some issues, there are some single points of failure on these systems or on these components, and what they are is basically this. So like I talked about a few minutes ago, that sometimes there are security issues, the devices cannot be trusted, there can be attacks on the aggregation layers like the gateways. If this gateway is hacked, then all of these three devices are actually useless, because even if they are sending correct data, it is being changed over here. And then because of all of this, ultimately the results that we are getting are incorrect. So these there can be more failure points over here, but currently we are looking at the failure points which are directly connected or directly concerning the devices itself, because ultimately the source of data are these devices, and if they are compromised, then the data is already compromised. So now the first pattern that we are looking at, the device identity. What we do in this pattern is we make sure that each and every device which is connected to the system is actually signing its own data and providing its own identity. Now, there is absolutely nothing else has changed in this architecture, but it is just that the devices are now directly providing their identity and adding a digital signature to the data, so that ultimately this data cannot be altered by any of these middle services which are there in the place before it reaches the actual sink and gets analyzed. Now, this can definitely help us somewhat in preventing man-in-the-middle attacks, because like we saw in the previous slide, if this field gateway is compromised, or if any of these connection points is compromised, then we are actually compromising the integrity of the entire system. But if the devices from the source itself are signing their data and they are sending this data to the system, which is already cryptographically secured, even if there is a man in the middle, it will be identified over here when you are consuming the data, because you will be able to see that the device which is registered in the system, which should be sending a data signed by a particular private public key, it is not signed by, because even though they are man in the middle, they will not be able to access the private keys of these devices, which are generally burned into the devices or cannot be tampered with. There are organizations or companies which are manufacturing these kind of devices which cannot be tampered with, where the keys are fully secured. So even if there is a man in the middle attack, it can be easily identified. So this is the first integration pattern, which is absolutely simple. It's just basically making sure that the device communicate with the rest of the system in a more a secured way by providing their identity and signing the data with it. So ultimately, it makes the system much more, you can say, secure and much more uh, integrated, and sorry, much the integrity of the system becomes a little more. Now, this was the easiest pattern because we were actually not doing much here with respect to blockchains. We were just taking the small aspect of blockchain protocol, which was cryptographically signing everything before it leaves the source. And but this is just a very simple start for integration. The second and more important integration pattern is the validation rules. And this is exactly what we saw in the scenario of the truck driver and the consumer, where devices are actually communicating with with the nodes of the organization. Now, the major difference between this pattern and the next pattern would be how devices are actually communicating with the blockchain network. Now, over here we have this network as the blockchain, which has where different organizations. Now, let's assume this particular organization, which has its own gateway and storage, is the organization which is the logistical partner, which is having their own trucks, and these are trucks in themselves. And this is the organization which is basically the retailer or the warehouse, and they have their one warehouse over here. So if the truck reaches the warehouse, then we will know that a condition can be met, and this analysis can be done on each of these nodes. So the partner who is running the trucks or making sure that the goods are arriving at the right time, they are actually able to fetch out the reports and do analysis on top of them, because they have their own nodes, and all the data over here is already secured and decentralized and immutable, so they can fully trust this data. And then the other party can also do the same on their set of nodes. So this is where the pattern is decentralized validation rules, and uh, this is much more common in today's systems, because this enables a lot of scenarios which are already there. It's just a matter of a change of a few things into existing systems, and then these systems are actually easily integratable with blockchain. So let me give you an example for that. So let's assume that there is a consortium or a group of companies which are coming together to create a network. Now, all of these companies have their own blockchain node, and they have connected them together to create a private permission network, permission, and so nobody else can join and validate or write data on top of it. And all of these companies are basically now having their own set of devices which are sending in data to their own nodes. For example, one of these companies is, let's assume, creator of pharmaceuticals or manufacturer of pharmaceuticals. So they are manufacturing, let's say, medicines, and these medicines have some specific um, composition points or ingredients which are sourced from a different supplier. Or actually, let me take a simpler example, which I was just reading the other day in the news, which was related to mobile phones and screens and all. So these days, actually, some of the manufacturers of mobile phones are putting the screens, and these screens are actually generated or manufactured by a very small, let's say, majority of suppliers. So if you look at a mobile phone which is manufactured by manufacturer A, and if you look at mobile phone which is manufactured by manufacturer B, they might be sourcing the screens from the same supplier. So let's assume that this screen supplier and the charger supplier and the supplier of um, batteries, and then finally the assembly point where all of these things come together and create a mobile phone, and then basically going on from there is the supply chain coming into picture. So all of these parties come together, create a blockchain network, and now the screen supplier is writing about how many screens he has provided, what are the dimensions and let's say quality of these screens, and then the battery supplier is providing information about the batteries, and he is writing on his own node on the blockchain network. And finally, when all of this information is being aggregated, then it can be easily verified at the assembly plant, where you can see that the supplier which is supplying the batteries has supplied these many batteries, and these many screens have been supplied by the screen supplier, and all of these things can be verified because they are physically present in the assembly plant. And there should be equal number of mobile phones if none of these things is um, uh, let's say not working, or not in a working state. So this is how basically all of the information can be tracked in a much more secure way in a supply chain scenario by combining this kind of pattern where the parties in the blockchain network can automatically send in data from their existing systems, because most of these factories of today are already smart factories, with IoT actually gaining a lot of uh, popularity in the systems of today. Some of these factories are already smart factories. They have IoT sensors and devices. All that is needed is hosting a blockchain node, connecting these sensors and devices to each of these nodes in their own premises, and then we have a blockchain and IoT integration in a real supply chain scenario. And all of these parties can then read the reports from their own node and create their own analytics, and how much was loss, how much was profit, and what was the causes of that, and stuff like that. So that this is the most common and uh, uh, blockchain and IoT integration pattern, where we are looking at decentralized validation nodes. And finally, the future pattern, which is like a little still a little few years away from now, is each and every device acts it as their own blockchain node. So this is a fully decentralized system where every device is actually writing data directly to a blockchain, and not through um, any third party or any organization coming in between. And this way basically all of these devices can actually connect and transfer value between each other. So this can be as easy as, or as simple as connecting, let's assume your home, at your home you are connecting your like we have these famous IoT examples of connected coffee machines and connected refrigerators and connected washing machines and all. So all of them will be writing data directly into the blockchain. And let's assume that if you want to pay the bill of electricity, all of these devices can actually transfer value directly on the blockchain to the electricity supplier by this means. So if they are consuming X number of kilowatts per day, then they can transfer that value on the blockchain, and it directly goes to the supplier. So this can be achieved, and a lot of possibilities can be achieved by this kind of integration. But the problem of this integration is it is in the present it is not scalable enough. It is basically the blockchains, they are limited at accepting and committing number of transactions per second. And as and when the number of blockchain nodes grow, the throughput becomes less and less. And the reason for that is the actual design of the systems itself. As we see that blockchains are fully decentralized systems, and all the data is stored at all the parties or all the nodes. So it takes time to replicate all this data at all the nodes. and that's why blockchain systems become a little slow than the normal systems. Because in normal systems you are writing it at only one place, in blockchain you are writing it everywhere. So because of that reason, if every device is sending the transactions to all of the to directly the blockchain, and we have a lot of devices in the market, then we have a lot of blockchain nodes in the network, and then it causes a lot of scalability issues. So there are efforts being made in the market or in the industry where we are trying to scale blockchains, and one of the efforts is where we are also looking at from the BigchainDB side on scaling the systems. And once we have enough scalability on the blockchains in general, I think we will be able to utilize this pattern much more. But at this moment, it's still a pattern which can be used for a small set of devices which can be connected together. It can be, for example, I can now remember a much better example for this kind of pattern is where cars and charging stations can be connected to blockchain. So if a car is an electric car, needs charging, and the charging station is also connected, then electric car can take the number of or the electric car can take the energy from the charging station and can pay back in a cryptocurrency, and the transaction will be completed between the two machines without any human interaction. And that's where actually this kind of pattern comes into the picture, where you have machine-to-machine interaction and a machine-to-machine market playing its role. But definitely there are a lot of things that can be improved before this can be used in a full-scale way. So primarily, these are the three patterns which we are looking at for blockchain and IoT integration. I explained them at a very high level because if we go into details of each and every cryptographic details and architectural details, we will not be able to cover it in this specified time. So I kind of ran through them on a pace where we could see the overall benefits. And in the next slide, let me also visit the benefits again. Like now we saw these three integration patterns on how blockchains are coming together with IoT systems and creating a verification and security layer on top. So what we are looking at here is again revisiting the benefits. There was definitely a need of less oversight because the primary reason for creation of IoT was less human interaction. So we achieved that by integrating with blockchains because of security. And then finally, we can do these machine-to-machine economy and automated transactions and value transfer by using the system, because in future, machines will be talking to each other and they should be able to transfer value with each other as well. So this is how basically we will achieve these benefits by integrating the IoT systems of today with blockchain technology. So I think that's all I have for now. Thank you so much for listening to me. I see there are 41 people, and thank you to each one of you for listening to me for 50 minutes. And please ask if there are any questions. We can take questions now.
Thank you, Engineer Gautam. Please, there are two questions I have sent to you.
Yeah.
Can you answer them, please?
They should be somewhere here. Yes. So the first question was, how can one create blockchain network for home automation? For example, I want to create a trust between my home and myself, and only I can access my home. So the way of basically creating a network between you and your home will be like all the devices in your home will be identified individually. All these devices will be basically having their own private key to sign the transactions, and you will also have your own identity on this network. So in this case, the owner of the devices and the devices themselves are all separate identities on the blockchain network. And then you can basically have this interaction layer in between these parties. For example, if you are sending a command to a device, or let's say you have you have a smart door in your home, and this door is connected to this blockchain network, and it will only open, it will if there is a message coming in only from your public key into the network. If you have not signed the message, then it will not be the door will not open. And that's how basically the secure identity and the signing of the data will come into picture. But everybody needs to have basically or each and every identity needs to be connected on the blockchain. So the second question that I have here is, what if the truck sent wrong location, which will be misleading and will result in wrong execution of the smart contract? Who verifies? It's a very good question, actually. So primarily, what we are looking at here is that when you are connecting an IoT sensor to a truck, and this sensor is actually signing all of its data, then as I mentioned in the briefly in the presentation itself, that there are devices which cannot be tampered with when you are signing the data. So if the IoT device is collecting data and signing it and sending it directly to the system, then it is automatically confirmed that this data is not being tampered with. If there was a man in the middle attack, like when you say, what if the truck sent a wrong location? In this kind of scenario, the wrong location can only come from one place, where you override the device and send the data directly to the blockchain network. But in that case, the data will not be signed by the private key of the device, and you will be easily able to verify that the data is not coming from the truck, but it is coming from some other person or place which is acting on behalf of the truck. And this is actually a typical scenario of a man in the middle attack. But the device itself should be fully hack proof, and that is those devices are actually available in the market today. So we are good there, I believe. There is another question: which consensus mechanism is most interesting for IoT? So definitely not proof of work, because it will IoT devices, if they are themselves connected to the blockchain, they will not be able to do that. I would say that a proof of stake or a proof of authority kind of consensus mechanism is more popular in this kind of area, because definitely we need more scalability, and proof of work actually is a lot more time and power consuming mechanism. So we would not be aiming for that kind of consensus, but a more simple, like proof of stake, for example. Every device or every let's say authority in the network can have some stake in the system, and they can sign the transactions or create blocks based on that stake. This can be something that can be that should be done ideally when it comes to consensus. There can also be a simple federated voting based mechanism also in private blockchains, like in supply chain and stuff. That should also be fine in this scenario. So there is a question: can you give some example where implementing blockchain will be a bad idea? Because I see it can be applied at most of the areas. Okay, let me think. So definitely, like I was actually in a meetup a few days ago, and somebody from the crowd asked this question, that why are we saying blockchain is like a ketchup which can be used with every kind of thing? Like generally we eat ketchup with all foods. So definitely blockchain is not a ketchup in the IT industry. It should not be applied everywhere. So there are places, I would rather answer it in a way which is a reverse answer to this question, that it should be used only in places where there is lack of trust and security. If you are good with those kind of things, for example, internally inside an organization, if there is an internal network of IoT devices which are basically just being used for aggregation of data, I don't think you need blockchain in those kind of scenarios. It is needed if and only if there are multiple parties coming together, and they don't necessarily trust each other because of commercial reasons, because of competition and stuff like that. Then only you need blockchain. So question 6, how do you reconcile timestamps between nodes so that payment can be made in real time in your example? So Generally, we do not use timestamps in blockchain which are generated by clients because of limitations of distributed systems, as we know. The time is actually calculated on block heights. So every node in the blockchain will be following the same block height. And let's say that if I'm sending a transaction to a blockchain network, then I will be actually, let's say, measuring time in terms of block heights, but not in terms of seconds or minutes, because that's how all the blocks will be able to coordinate with block heights. So everybody will be mining the block at this at that particular height, and then we will be able to coordinate. There will definitely be some sort of padding needed in this kind of scenario as well. There will be some milliseconds or seconds of delay, but that is actually in terms of financial settlements, that should be fine. I mean, today we are looking at financial transactions which are actually taking days across borders in supply chain scenarios. I think actually we can bring that down to minutes, but that's how, if you really need a very, you can say, reliable time stamping mechanism, you should be using block height and block timestamp. So every block will have its own timestamp, and block height is another way of doing it. Okay, how to recover if one of the two-party side transaction data damaged? So basically, because the other party already has the data, there will be what we call in this kind of scenario is generally there will be more than two nodes. And once the data is damaged, or once the node is not behaving properly, what we say is this is a node which is not in sync with the network. So all you need to do is just resync with the network, and the data which is available on the other majority nodes will be synchronized with you automatically. So this is another advantage which is kind of implicit. It is not like something which we talk about a lot, but data replication and automated backup is another a very good let's say benefit of blockchain, because all you need to do is delete all your data and synchronize with the network again, and you have the latest data already. So I think I was able to answer your question, but feel free to comment if there is anything left in answering, or if I was not able to answer, then I will take another try. Otherwise, I think all the questions are covered.
Okay, thank you, Engineer Gautam, for this webinar, and thanks for all participants here.
Thank you so much.
Thanks.